بسم الله الرحمن الرحيم والصلاة والسلام على محمد وآله الطاهرين. السلام عليكم ورحمة الله. مستر ياسر، مستر انتصار، مستر صفا، مستر أحمد، مستر عامر، مستر حسن عباس، مستر انتصار، مستر ماجد، مستر صفا، مستر ياسر. إن شاء الله تعاطف مقبول. Mrs. Lovna, assalamu alaikum. Okay, Mrs. Hana, assalamu alaikum. That's right. We are about to talk about timers in microcontrollers. Okay, this some timers in AVR. What about the packages? Can you install Purchase and Code Vision? Mr. O'Day, assalamu alaikum. Mr. O'Day. Mr. Al Hashem. Okay, in AVR we have 3 timers: timer 0, timer 1, and timer 2. Okay, these timers can work in 4 modes. Mode normal, mode CTC, mode fast PWM, and mode correct phase PWM. Okay, prepare in English for you this file. Okay, don't worry. Here we have 3 registers. TCCR means timer counter control register. Timer counter control register. TCNT means timer count. Each time the value of timer is registered in this register. Okay, T count. And the third one, OCR. OCR means output compare register. That's the value of T count. Each time is in this mode. Is comparing with OCR. Each time the value of 2 of them is equal, maybe we have an interrupt. Okay, and 2 registers named TIFR or timer interrupt flag register. Timer interrupt flag register. Okay, and TI mask means timer interrupt mask register. That's right. And this registers is for timer 0, timer 1, and timer 2. For example, TCCR 0, TCCR 1, and TCCR 2. Timer counter control register for timer 0, for timer 1, and for timer 2. Timer 0 and timer 2 are 8-bit timers, and timer 1 is a 16-bit timer. Okay, and timer 1 is a more complex timer, VC. Here, timer counter control register and the bits of it. Timer counter control register. These 3 bits, CS, CS 000 for timer 0, bit 0, bit 1, and bit 2. This 3 bit is for the speed of clock. CS means clock speed, Okay, the speed of clock. This 2-pin WGM wave generation mode. Wave generation mode pin here in pin 6. The wave generation mode pin 0 and wave generation mode pin 1. These 2 pin 3, bit 3 and bit 6. Okay, these 2 pin are for mode of work, wave generation mode. Okay, this for mode normal, CTC, fast PWM and phase correct PWM. Okay, in this table we can see mode 0 and WGM 1. 0 means working in normal mode. 1 working PWM phase correct. This mode is for CTC. CTC means clear timer on compare match. I said, for example, you are starting from 0 in timer 0, 1, 2, 3, and this timer this is a T count, timer count. Okay, and this timer OCR may be initialized by 100. Okay, by you. 0, 1, 2, 3, 4. When this is 100 and OCR is 100, T count is 100 and OCR is 100. This is a compare match. Okay, each of them are the same, and this time the timer will be cleared. CTC means clear on compare match. Okay, and this mode is for fast PWM. We see these 4 modes in detail. And we will see in this 2 pin COM means compare output mode, compare match output mode. Okay, LMS. And this pin FOC means force output compare bit. We have 3 bits: OC0, OC1 and OC2, each for each of these timers: timer 0, timer 1 and timer 2. For timer 2 we have 2 OC, OCA and OCB. We see later. Here in normal mode. Okay, normal, CTC, fast PWM, phase correct PWM. The first mode is normal mode. Okay, we see here again this timer counter control register. Okay, these 2 pin bit 3 and bit 6 must be assigned as 0, 0. Okay, here 0, 0. That means we are in normal mode. Okay, 8-bit timer counter. This means a simple timer counter, 8-bit register. Okay, that's right. In this mode, these 3 bits CS0 to CS2 clock select. Okay, these 3 bits are shown their task in this table. 0, 0, 0 means timer is stopped. Okay, no counting or no improving. Okay, 1 means system clock. Okay, for example, if your clock frequency is 1 megahertz, your speed is at 1 megahertz. Each time interval is 1 microsecond. Okay, if these 3 bits are 2, means that 2 means clock divided by 8. System clock divided by 8. 3 clock divided by 64. 4 clock divided by 256. 5 clock divided by 1024. These items from 0 to 5. 0 for clock selects mean timer is stopped, متوقف is stopped. From 1 to 4 to 5 means clock itself clock بلا تقسیم. Okay, then clock divided by 8, clock divided by 64, clock divided by 256, and clock divided by 1024. Okay, these items for timer. Okay, for working in timer mode. But these two items, 6 and 7, these two items, timer is working in counter mode. We have two modes, timer. What's timer? Timer is for let it, for example, level of water behind for example. Okay, or you may measuring rate of passengers in an airport. Okay, or in bus station. Maybe occurring in seconds or minutes or months or years. Okay, this means counting external events. But this timer mode, you are in fixed intervals, maybe 1 microsecond each of them, or 1 divided by 8 microsecond each item. But in this we are counting external events. Okay, isn't in our hand. That's right. 6. The timer is counter mode. That pin T0, external input pin T0 is working by is activating by falling edge of T0. That's right. And this item, لبه پایین رونده means falling edge of T0. 7, we are in counter mode by rising edge of T0. That's right. This register T count, each time the value of counter is registered in this register. Okay, isn't bit addressable. Each time is available for reading and writing. And this register TIFR means timer intra-flag register. Okay, for working with interrupts. These two pins are for timer 0. These two pins for timer 0. These two pins for timer 2, and these 4 pins. These 4 pins for working with timer 2 or timer 1. Okay, but these 2 pins for timer 0, timer overflow timer overflow. Timer overflow for timer 0. And this pin, output compare flag. Output compare flag for timer 0. Okay. Counterpart of if for timer 2. Timer overflow for timer 2. And timer output compare flag for timer 2. That's right. And this 4 bits is for timer 1. We see later. Timer overflow for timer 1. Output compare flag for timer 1. Output compare flag A and output compare flag B. In timer 1 we have 2 compare flags, OCR A and OCR B. For example, we are counting from 0, 0, 1, 2, 3, and OCR A maybe is 100, okay, and OCR B is 200. 1, 2, 3, 4. When T count is 100, you have the first compare match. T count with OCR A, okay? T count with OCR A. You are increasing 101, 102, 103. Here, the second compare match, 200 and 200. 200 in T count and 200 in OCR B, okay? These 2 pins is for that events. Output compare flag, flag timer A, flag for timer 1 for A register, and this is output compare flag for timer 1 in B register. And this is ICF, means input capture flag. We see later. Input capture flag is for timer 1 is using in for capturing an input register, and reading writing that register into T count. We see later. We are for timer 0 and in normal mode. Normal mode is a simple mode. The simplest mode is normal mode, okay? That these 2 pin bit 3 and bit 6 are assigned as 0, 0. That means normal mode, and these bits is for clock selecting. That's right. See example. Generating a clock pulse. Generating a clock pulse, but this duration 512 microseconds, okay, for each pulse. Duration of it is 512. That means we have in this item 256, and for on cycle 256, okay. The sum of these 2, that means 1 clock cycle is 512, okay, microseconds. That's right. We see the code. Include mega16.h header file. For example, define install 8 megahertz. Void main. DDRA is FF. That means what was DDR? His name. 22% is in the class. مثل ابتسام، مثل احمد، Mrs. علا، مثل عامر، Mrs. بیادر، Mrs. دنا، مثل حامد، Mrs. حنا، Mrs. حنا، مثل حسن عباس، مثل انتصار، مثل لبنى، Mrs. لمعه، مثل ماجد، Mrs. نعیمه، Mrs. نور، مثل عدی، Mrs. صفا، مثل سعدت، Mrs. سرا، مثل یاسر and مثل علی عبدالعباس. Okay. مثل okay, DDR was data direction. Okay, data direction for port A is FF. That means output. We assigned port A as output, and port A is 0. Okay. Timer counter control register for timer 0 is 00. That means we assigned timer 0 as normal mode by 00. Here 00 means these two bits are 0. And these three bits are 0. What does mean? That means the timer is stopped. Okay, we are in a normal mode and timer is stopped. That's right. For example, we can comment here. Timer is working in normal mode and timer here is stopped. That's right. T count 0 is 0. That means when the timer is started to timing, we start from 0. From 0 to this timer is 8-bit. From 0 to 255. Okay, 255. Eight-bit timer counts from 0 to 255. That's right. Infinite loop while 1. Port A dot 0 is 1. Delay. We use a delay function. Delay function is written by us. Okay. Delay. Then port A dot 0 is 0. Again delay. What about delay? How many times is how many seconds is delay or waiting? This is delay. Void delay, a function written by us, for example. Delay. TCCR0 is 2. 0, 0, 0, 0, 0, 0, 0, 1, 0. That means you have تأخير in my sound, you have delay in my sound. مثل عبدالعباس. I turn off my camera for better quality. No delay. Okay, you said about this item. I turned off my camera, okay, for better quality. Oh, okay, I knew. I turned off my camera for better quality. That's right. In delay, timer counter control register. These three bits are clock select. Okay, this bit and this bit are bit 3 and bit 6 are assigned as 0. That means we are in normal mode. But these 3 bits are 2. That means we are in this item. Okay, this item. That means clock is divided by 8. That's right. Okay. Our crystal is 8 megahertz. When we divided it by 8, means timer clock is clock by 8. That means 1 megahertz. 8 megahertz divided by 8 means 1 megahertz. That's each time interval or each T cycle is 1 microsecond. Okay, each T cycle is 1 microsecond. TIFR is TIFR ORed by 00001. Okay, what does TIFR? Timer intra flag register. Timer intra flag register. Here, this is TIFR, and this is bit 0. Timer overflow. TOV means timer overflow. Timer overflow for timer 0. That's right. For example, we are counting from from 0, 0, 1, 2, 3, 4, and go to 255. Okay, this is the top of the timer in 8-bit, and after it we return back to 0, and this time timer overflow is set by microcontroller. Okay, by timer controller. Timer overflow means we have reached to top of the time. From 0 to 255 means 256 time intervals in here T cycle, and in here means 1 microsecond. That means when timer overflow 0 is set, we reach from 0 to 255. That means 256 microsecond. Okay, because about it clock cycle, each section, this section and this section, 256 microsecond, and 256 microsecond, both of them means 512 microsecond. That's right. Okay, here when timer is started by 1 megahertz speed. Okay, 8 megahertz divided by 8 means started by 1 megahertz speed in normal mode, while timer intra flag register and by 0000001. That means we are masking other items than timer overflow. That means all of it means TIFR.0. 0 pin means timer overflow. Okay, each item 0, 1, 2, 3, 4, timer overflow is 0. When we reached 255 and clock reached, we go from this top to button, timer overflow is set. Okay, while timer intra flag register .0 not staggered. Stop here. That means wait until overflow. Okay, 0, 1, 2, 3, 4. Here this item is 0, and not of it means wait. This is true. All of these items is true. While true, this item semicolon means no operation. No operation means stop here. Stop. When timer overflow is occurred, that means 256 microsecond. Okay, we go and jump from this statement to this instruction. Okay, that means all of this means wait for 256 microseconds. Wait until overflow occurs. Then Timer or timer interrupt flag register is timer interrupt flag register ordered by 00001. That means clear timer overflow for using for another ones. Okay, clear this bit by us. This programming mode means polling method. We have two methods for working with peripherals, for example with timers: polling and interrupt. Maybe we spoke in last sessions. Okay, these two methods, polling and interrupt. In this example we are working in polling method. Polling. That's right. And after it, timer counter control register is 00. That means stop timer 0. Why? This 3 pin means clock select. If what was 0 here, 000 means stop the timer. Okay. No clock or متوقف or timer is stopped. That's right. We see this delay function. This delay function is producing 256 microsecond. Okay. In the main function, port A.0 is 1. Then using delay means wait for 256 microsecond. Then port A.0 is 0. Another one, delay means another 256 microsecond. All of these items means a clock pulse. All of them, some of them is 512 microsecond. That's right. As here, generating a clock pulse with 512 microsecond. That's right. Go to another example. A clock pulse by 400 microseconds. 400 microseconds means each item off on, each of them is 200 microseconds. 200 microseconds instead of 256. Okay. Here the code, the main code is as last one, and only the delay is changed. Okay, delay function, void delay. T count is instead of 00 is changed to 38. That means 38. I type it 0011 means 3 and 81000. Okay, this is 38 in binary. مثلا انتصار, what mean A0 is 0 here. Mr. Entasar, we are generating a clock pulse on bit 0 from port 1. For example, maybe on bit 0 of port 1 you have connected an LED, okay, on port A.0. Here port A.0 is 1, that means LED is on. Wait for 256 microsecond, then LED is off. Pin 0 from port A is 0. That means LED, for example, is off. Another one, wait for 250 seconds. Okay, مثلا sir. أحسنتم. Port A, pin 0. Mrs. Abbas, these items are example for working with timers. An example for working with timers, we said Here we are in timers. Okay, this session we are working with for timers. In AVR we said we have 3 timers: timer 0, timer 1, and timer 2. Timers maybe works in timer mode or counter mode. Okay, in timer mode we have 4 modes. In timer mode we have 4 modes: normal mode, a simple mode, normal mode, CTC mode means clear timer on compare match, we see later, and 2 PWM modes: fast PWM mode and phase correct PWM mode. Okay, here we are in the first one, normal mode in timer, and this is an example for working with timers only. Okay, مثلا حسن عباس I answered you or not? This is a simple example for working with timer 0 in normal mode. That's right? مخلص مخلص. خب here generating a clock pulse for this duration 400 microseconds. Okay, that means each time 200 microseconds for low time and 200 microseconds for high time. Here T count is as I typed here, another one, 38 means 0011 81000. That's right. This is 38. Okay, clock select these 3 pins, pin bit 0, 1, and 2 is assigned as stopped. Okay, 8. Oh no, this is T count, not timer control. T count is 38 in hexadecimal. What is in what's it in decimal? This is correct or not? 38 in hexadecimal. What's in the decimal? Please tell me. This is T count. This is a timer control register. Okay, what about T count? That means each item we start from 38 in hex. You go, Musali Abdul Abbas. You go from the class. Oh, I think you said Ozri. No, in Ashri or Ashra. I don't know. In decimal. Okay, I read it at Ozri that you will go out. Ashri or Ashra or Ashra. Okay. Tell me 38. أحسنتم. مثل أحمد سامي. No. Tell me what is it and why? Oshri. أحسنتم. أحسنتم. Don't use calculator. Okay, we say, for example, we say 28 in hexadecimal. 28 in we say 20 means 2 divided by 8 multiplied by 8, and 8 2 multiplied by 10, and 8 is multiplied by 1. Here 38 in hexadecimal is 3 multiplied by 16 powered by 1 plus 8 multiplied by 16 powered by 0. Okay, for calculating in Oshri in decimal. That's right. That's right. Means 48 plus by 8 means 56. Okay, 56. By this formula. Accent. That's right. That's right. Is wrong, not correct. T count is 56. 56. That means we start not from 0. We start from this item, from 56. 56, 57, 58, 59, 60, 61, 62, to top. What's the top? Top is 255. That's right. That means, but this initialize from 55 to 255. We count 200 microsecond. Each item was 1 microsecond. From 55, that means from 50 second to 255, and time is another T cycle for going to our flow. That means from 56 to 256. That difference of it is 200. 200 multiplied by 1 microsecond means 250, 200 microsecond. Okay, here each item for low and for high 250, 200 microsecond. That's right. This is because of this item, T count is initialized by 38 in hexadecimal, or 56 in decimal, or in Oshri. Okay, and that's right. Timer counter control register. Timer counter control register again is set as 000010. Here 0 and 0 means we are in normal mode. 010 for clock selects mean clock divided by 8, or clock cycle is or crystal is 8 megahertz divided by 8 means each item, each T cycle is 1 microsecond. Okay, that's right. Result of these two statement means 200 microsecond waiting. Okay, 200 microsecond time generation. Here, while TIFR and by 01, that masking selecting only timer overflow with 0. Okay, from this register timer intra flag register. Timer overflow for timer 0. That means wait. Excuse me. Wait for 200 microsecond. After 200 microsecond, that's we have our flow. We go to this item, and TIFR is TIFR by 1. That means clear the timer hour flow for the next times. Clear timer hour flow. Here we have a stop timer again. A stop timer for using another one in main section. Okay, that means this item, difference of this item with this item is here in T count only, in T count. we had here T count is 0. We have here T count is starting from 56. Okay, that we here had a delay for 256 microsecond. Here we have a delay for 200, only 200 microsecond. That's right. That means clock generated over pin 0 of port A in duration of 400 microsecond. That's right. Okay, we had two examples for normal mode. Another mode, CTC mode. CTC mode means clear timer or in or other compare match. C means compare match. That's right. We type in English, don't worry, okay? Maybe to tomorrow, maybe. In CTC mode, we start from, for example, 0 and going up and up and up, increasing the T count before reaching to top, to FF. We reach to OCR. T count, for example, OCR is an 8-bit register, okay, and completed by us, written by us. For example, I write to OCR 100, 50, another one, okay. For example, 100. T count is 0, 1, 2, 3 is counting. When T count and the timer controller is each time comparing these two items, T count and OCR. T count, OCR. We don't see compare match. T count. Here, T count is 100 and OCR is 100. Okay, and in comparing, these two registers are the same, and we are in compare match. Okay. In this mode, we say clear the timer in compare match. That means we start from 0 to 100 and don't go up and clear the timer and start again from 0. 0, 1, 2, 3, 100. Again, go back from 0, 0, 1, 2, not go upper 4 to FF. That's right. This means CTC, clear timer in compare match. That's right. Another one, we have OCR, T count, and timer counter control registers for timer 0. Here, this register, these two bit 3 and bit 6 must configured as 0A, 0, 1. For normal, we had 0, 0. Here we have 0, 1. These two bits, bit 3 and bit 8, wave generation modes. Okay, 0, 1 means mode CTC. That's right. These 3 bits again for clock cycle speed. Okay, 0 means timer is stopped. 1 means clock cycle itself. 2 means clock cycle divided by 8. 3 means clock cycle divided by 16, etc. That's right. These 2 pins compare match output pin mode. We see here. Okay, these 2 pins. Here. These 2 pins. For each timer, for example, for timer 0, we have an external output pin, named OC. OC means output compare match. Okay, maybe OC0 over PB.3. Okay, I type here PB.3 or OC0. Okay, for example, in data sheet, port B dot I connect my charger, excuse me. Did you hear from for explosion in Afghanistan? In a school, in girls' school? This is my Instagram. Morad Zade Sarda. This is my Insta. Okay, see my story in Insta. I put a story for girls' schools, an explosion by terrorism in Shahr Mubarak. A bad news, very bad. Okay. Here. These two pins. We said we have port for example, port B.3 or OC. OC0 means output compare match for timer 0. Output compare match for timer 0. Okay. What about it? Each time, but these two pins, but these two bits, we can configure the functionality of OC. Okay, 0 0 1 2 and 3. 0 0 غير فعال, passive. Okay, that means OC isn't connected to timer. That means port B.3, not OC. Okay, its functionality. 1 مثال عبد الباس toffee, I don't know, مثال عبد الباس toffee off. أحسنتم. Not working, disconnected. OC is disconnected from timer. أحسنتم, غير فعال. 1 toggling OC pin in در وضعیت تطابق is as Arabic. Okay, Persian is as Arabic. در وضعیت تطابق means في الوضعیت التطابق. در is في. وضعیت is the same in Persian and Arabic. تطابق in Persian and Arabic. Okay. در وضعیت تطابق, in Arabic we say في الوضعیت تطابق. In compare match. Okay. When compare match occurred, OC is toggled. Is toggled means if was 0 is 1. If was 1 is 0. Toggled. Toggling means negating. Okay. To clear in compare match. في الوضعية تطابق. Clear. For example, when compare match occurred, we clear the OC. OC is 0. And this time set the OC in this في الوضعية تطابق. Okay, in compare match. We use these two items lower. Maybe almost we use this item toggle. Toggling in compare match. Okay, that means 0 1 0 1 0 1. Constructing a clock pulse over this item, over OC 0. Toggling tabdil. ahsantum. Tabdil. Inverting. Okay, tabdil from 1 to 0, 0 to 1, 1 to 0, 0 to 1. ahsantum. Here we see these two pins, wave generation mode. 1 0 means CTC. Here we are in CTC mode. Okay, and these two items means 0 1 is for toggling. Okay, that's right. And this is 4 clock cycles. Okay, here CTC mode. We explain these two items 0 0 0 1 1 0, and for toggling we set 1 means 0 1 0 1 means toggling. Okay, toggling the OC pin. Frequency of OC. موج ایجاد شده، موج موجود or wave موجود over OC. Okay, frequency of it. Frequency clock IO. For example, here we need peak for these timers or Arduino. No, here this item we are working with 80 mega AVR, not Arduino. Okay, we decided that don't work with hardware. Only in this semester we work in simulation. Okay, because of the price. We said about it. Maybe expensive for. Okay, only. Yes. After this, after working with 80 mega, we go to Arduino. In Arduino, we use timers, interrupts, etc. Okay. This weeks, we are in working with microcontroller with 80 mega. Okay. Okay. After 80 mega, we go to Arduino Uno. This time. We are working with microcontroller, not Arduino. Okay, that's right. Frequency of OC0. Frequency of OC0 is frequency of clock IO. I zoom it. Frequency of OC0 is frequency of clock. In these examples, for example, 8 megahertz divided by 2 by n by OCR0 plus by 1. Why divided by 2? Because of low section and high section. Low, high. For example, this in last example, 250 second, 250 second. All of them is 400 microsecond. 200 microsecond, 200 microsecond, a clock pulse by 400 microseconds. Okay, this is 2, low and high. N is pre-scale. For example, by clock select, we say clock or clock divided by 8, or divided by 16, or divided by, for example, 64 divided by 256, or divided by 1024. That's right. This item is pre-scaling, slowing the speed of clock. The microcontroller is working by clock itself, for example 8 megahertz, but the timer section is working by a slower clock, maybe clock itself, or clock divided by 8, clock divided by 16, etc. That's right. This is N, pre-scale. I don't know what do you say, Masali Abdul Abbas, on stop? What do you mean? I don't know. For timers, I don't know. What you said. Oh, okay, if isn't any question, divided by 2, divided by N, pre-scale. Okay, pre-scale is, for example, 1, 8, 16, 64, 256, and 1024. Okay, this is pre-scale. This is N. And OCR plus by 1, but because we start from 0, not from 1. For example, OCR is 99. For example, 99. I start from 0, 0, 1, 2, 3 to 99. All of them is 100. OCR is 9. OCR is 9. Okay, from 0 to 9 means 10. That means 1 plus by OCR, not OCR. What was OCR? OCR is output compare register. OCR is output compare register. That's right. Okay. And here an example for working with timer in CTC mode. Clear timer over compare match. That's right. Executing and clock pulse with 5 kilohertz frequency. Our pin OC0. Okay, a clock pulse generated our OC0 but by 5 kilohertz. That's right. Here, include mega 16.header file, define install 8 megahertz, void main. DDR B is FF, that means port B is assigned as output, port B is 0, timer count is 0, that means we start from 0. Okay, OCR is 63, that means 63 0x 63 means 6 multiplied by 16 powered by 1 plus by 3, or 3 multiplied by 16 powered by 0. Okay, that means 6 multiplied by 16 plus by 3. That means 19.6 plus by 3 means 19.9. That's right. 6 multiplied by 16 is 96. Plus by 1 and by 3 means 99. Let's start from 0 to 99. That means 100. 100 counting. Okay, 100. Okay, and here TCCR, timer counter control register. TCR is 00011010. Here 01 no 01 pin 6 0 pin 3 1 means CTC mode. We are in CTC mode. Clock cycles CS 010 means clock divided by 8. That means clock is 8 megahertz. Clock by divided by 8 means as previously 1 megahertz, or T cycle is each T cycle is each time interval is 1 microsecond. Okay, 1 microsecond in CTC mode, and starting from 0 to 99. That means 100 microsecond. Okay, but here these two pins COM means compare match output pin modes or mode. Okay, that means functionality of OC0 pin. We saw lastly 01 is toggling OC0. Toggling OC0. Here toggle OC0 on compare match, and speed is by 1 microsecond each T cycle. Okay, that's right. While 1 semicolon, that means while 1 no operation. That means stop here. Stop here. That's right. In main we don't work anything. Okay, we don't work anything, no operation. But here our timer is set as working in CTC. Okay, and is working, is active, and counting from 0 to 99, and after it OC is toggling another one from 0 to 99. OC is toggling from 0 to 99. OC is toggling, and we see on our OC0 a clock cycle. Okay, each item of it is 100 microsecond. A clock pulse is 200 microsecond. Okay, a clock pulse CP over OC0 is the duration of it is 200 microsecond. Okay, and here 200 microsecond. Okay, but about the duration, this is duration, this is T. T is 200 microsecond. What about F? F is 1 per T. Okay, F is 1 per T, means 1 over 200 microsecond. That means 5 kilohertz. Okay. A question: Here's a question. I typed 1 kilohertz, K in lowercase, Z in lowercase, H in uppercase. Why? For yourself. Why correct is typing H in uppercase? Why? K is lowercase, Z is lowercase, H is in uppercase. Don't answer? Because H is name of a person, a scientist. Okay, H Hertz, Hertz. Here, Hertz. Mrs. Lovna is typing. His Hertz is name of a person. Kilo is a prefix. Okay. HZ means Hertz. اصلا نو بدای کلمه name of a person. بدای کلمه hertz. Okay, hertz is the name of a person, and we use as uppercase. For example, dB. Okay, مخلص. dB means decibel. D is in lowercase, B in uppercase. By Bell is name of a person. Bell, B-E-L-L. Okay, but Deci is isn't a person. Decibel. B is in uppercase and D is in lowercase. Here, we said. We generated we generated a 5 kilohertz clock over OC0. That's right. And here is the computing. The clock cycle divided by 2 divided by prescale. Here 8 divided by 1 plus by OCR. OCR is 99 plus by 1 means 100. That all of them is 5 kilohertz. H in uppercase, Z in lowercase. That's right. Okay. Okay, the time is over because in 8 minutes later, you have some of you have a class with Dr. Shakur. Mr. Intisar said, maybe we know when the end of course exam will be and whether there is an exam or assignment in the coming days. For Mr. Intisar and for all of you, Mr. Naime, how to collect subject grades. All of you, pay attention. We don't have any hardware, okay? Only we have simulation. From these times, maybe each week or 2 weeks, okay? We have one simulation, one exam, one exercise. For example, each of them a 2 square, okay? Exercise. This is PBL, project-based learning. Okay, this is all of the scores. Maybe in final exam we have a final exam at 5 scores only, or lower than it, 5. Okay, all of our scores is by simulation, by exercising, not hardware, not presentation, only by simulation. Okay. In last session, we said about the first exercise or not? Maybe not. Okay. We said about 2 7 segments. Oh no. Oh, no problem. Excuse me, I disconnected. The problem was from my side, no from your side. Okay? Do you hear me? Asantum. This is end of class. Okay? I said that don't worry about exercises. Exercise is very simple. Okay, by doing exercises we learn the fundamentals. Okay, exercise, and at the final we have a small final exam. Okay, that's right. If there's any question, this is the end of class. مخلصين Mrs. نعيمة مخلص بس انتصار Mrs. Abbas why oh don't worry Mrs. Abbas مخلص Mrs. أنا مخلصين don't worry about our exam, don't worry. Okay, only you should do your exercises. Okay, your simulations. If you do your simulation, don't worry about the score. That's right. Ms. Muhammad Mokhlesim, Ms. Hassan Abbas, because we are employed. Don't worry, Ms. Hassan Abbas. Mokhlesim, Mrs. Noor. No. First Allah, second Allah, third Allah, all Allah. Okay, only Allah, only God. No us. Mrs. Abbas said Mokhlesim, Mrs. Abbas Mokhlesim, and Mrs. Naima Mokhles. No. كلنا إن شاء الله. مثلا مخلص. Mrs. Abbas خیلی ممنونم از شما. You all of you know Persian law, okay? خیلی ممنونم از شما means ممنون is Arabic. خیلی very or مخلصیم تبریک for Eid al-Fitr, but at tomorrow I said مبارک لكم Eid al-Fitr. Okay, Allah يحفظكم, and I type في أمان الله.